Hi again. So, siguro naman nakita niyo na at saka you have tried solving the zero order kinetic problems which I have presented in my previous video. So, ngayon naman we are going to try to solve the first order kinetic problems. So, let's have a good time in solving first kinetic problems. First order kinetics, problem number 1. The amount of active ingredient in a tablet at 4 and 12 months after preparation of a product was found to be 365 mg and 341 mg per tablet respectively. If degradation follows first-order kinetics, calculate the rate constant of degradation of the active ingredient. So for this problem, it is specified that it follows first-order kinetics. So let us try to know the given. 365 mg is C1 at time 1, which is 4 months, and 341 is C2 at time 2, which is 12 months. Now we are looking for the rate constant of degradation. For first order kinetics, to look for K, we have this formula. So K is equivalent to the natural logarithm of C1 minus the natural logarithm of C2 over T2 minus T1. So ln C1 minus ln C2 divided by T2 minus T1. Now let's substitute. So C1 is 365. So natural logarithm of 365 milligrams minus the natural logarithm of 341 milligram divided by 12 minus 4 months. If you are you need to have a scientific calculator to compute for this. So if you input this in a scientific calculator, the result will be 0.06801 milligram. So 12 minus 4 is 8. So K is equivalent to 0.06801 milligram divided by 8 months. So K now is equivalent to 0.0085 milligram per month. There is also another way of finding the rate constant of degradation of first order kinetics with a different formula. So the formula is K is equivalent to negative 2.3 times the log of y2 minus the log of y1 divided by x2 minus x1. The y here means the concentration and x represents time. So, with this given, let us substitute. So, K is equivalent to negative 2.3 times the log of 341, which is the second concentration, C2 or Y2, minus the log of the first concentration, Y1 or C1, 365, divided by 12 minus 4. So, X2 or T2 minus T1. So, inputting this in the scientific calculator, you will get this answer. 0.06793851657 divided by 8 months. So K now is equivalent to 0.00849, and if we're only going to use or to use 4 places, so still K is equivalent to 0.0085 per month. So whichever formula you are going to use, you will still arrive at the same answer. Problem number 2. A product degrades according to first order kinetics. When prepared, the concentration of the active ingredient was 23 microgram per ml, and after 5 months, the concentration of the active ingredient was 21 microgram per ml. Calculate time when concentration of active ingredient in the product will be 17.5 microgram per ml. So, in this problem, let us try to know the given. 23 microgram per ml is the initial concentration at time 0. 21 microgram per ml is the CT at time 5 months. Now, what is being asked is to calculate the time when the concentration of the active ingredient will reduce to 17.5 micrograms. Looking at the given, there is an initial concentration. So, there are two approaches to solving this problem, or two formulas can be used to solve this problem. The first is this formula. ln-CT is equivalent to ln-CO minus KT. So, ln is the natural log. To find K from this formula, so let us try to derive. So, negative KT transferred to the other side, this becomes positive, is equivalent to ln-CO. And then ln-CT, we will transfer it to the other side. Since it is positive, it becomes negative. So therefore, KT is equivalent to ln-CO minus ln-CT. To look for K, so the formula now becomes ln-CO minus ln-CT divided by T. Let us substitute. Initial concentration is 23, so ln 23 microgram per ml minus ln 21 microgram per ml, which is CT, divided by the time 5 months. Again, if you input this in the scientific calculator, you will get this value of 0.09097177821. Now, divide this with 5 months. So, our K now is equivalent to 0.01819 per month. Since we already know the K, we can proceed to knowing the time for our CT of 17.5 microgram per ml using the same formula. So, we will use the same formula. Now, our CT now is 17.5 and no longer the 21. Okay, so from this formula, we will derive the formula for time. So, time here is equivalent to ln-CO minus ln-CT divided by K. Substituting, so ln-CO is ln-23 minus ln-17.5. So, this is our new concentration divided by the K, which is 0.01819 per month. So again, if we input this in the calculator, scientific, this is the value that we get, 0.273293335 divided by the rate constant of 0.01819 per month. So, our time here is equivalent to 15 months. Ano ibig sabihin yan? Meaning, from time 0, which is a concentration of 23 microgram per ml, after 15 months, the concentration of the preparation will now become 17.5 microgram per ml. The second approach to problem number 2 is by using this formula here. So the formula is log CT is equivalent to negative KT divided by 2.3 plus log CO. So we will derive how to compute for K from this formula. So this negative KT divided by 2.3, we will transfer it to the other side. So this becomes positive now. So KT over 2.3 is equivalent to log CO minus the log CT, because this comes from the other side. So it becomes now negative. So, KT divided by 2.3 is equivalent to log CO minus log CT. Now, how do we get the 2.3? So, we will multiply both sides with 2.3. So, this will be cancelled. So, ang maiiwan na lang is KT is equivalent to 2.3 times the log CO minus the log CT. To get K, so this is equivalent to 2.3 times log CO minus log CT divided by the time. So let us substitute. 2.3 times the log 23, which is our initial concentration CO, minus the log 21, which is our CT, divided by 5 months. So again, if you input this in the scientific calculator, you will get the value of 0.09086964495 divided by 5 months. So our K now is equivalent to 0.011817 per month. We can now proceed to look for the time when the product becomes 17.5 microgram per ml. Again, we will use the same formula. And from this same formula, we will derive how to compute for time. So time will be equal to 2.3 times the log CO minus log CT divided by K. So 2.3 times the log 23, which is your initial concentration, minus the log 17.5, because this is our new CT here, divided by the K, which is 0.01817. So this one, after inputting in the scientific calculator, you will get 0.2729865186 divided by the K, which is 0.01817. So, our T now is 15 months. Kasi nga ito siya is per month ito siya. So, ano ibig sabihin yan? Meaning that at time 0, your drug was 23 microgram. But after 15 months, it only now becomes 17.5 microgram per ml. Problem number 3. A product is ineffective after it has decomposed 10%. At the time of preparation, the concentration of active ingredient in the product was 500 mg per ml. After 12 months, the concentration of active ingredient was 491 mg. What should be the expiration date if degradation follows first order kinetics? Okay, from this problem, let us now know the given. So, 500 mg is the initial concentration at time 0, while 491 is the CT at time of 12 months. So, these are the three givens. But it was also mentioned that the product becomes ineffective after decomposing by 10%. So, decompose 10%, that would mean degradation of 10% means that the active ingredient is only 90%. So, 90% of the initial concentration, which is 500 mg, is equivalent now to 450 mg per ml. Now, let us use this first formula. LNCT is equivalent to LNCO minus KT. So, to find K, so you have K is equal to LNCO minus LNCT divided by T. By substitution, CO here is 500, so LN 500 minus LN 491 divided by 12 months. So, this one here will give us 0.01816397063 divided by 12 months. So, our K now is equivalent to 0.0015 per month. Since we already know the K, we can now proceed to know the time for the product to degrade by 10%. So, using the same formula, LNCT is equivalent to LNCO minus KT. So, time is equivalent to LNCO minus LNCT divided by K. So, by substitution, LN 500 minus LN 450. Why 450? Because this is now the new CT. Because after decomposing 10%, your 500 becomes 450. So, this is the new CT. Divided by the K, which is 0.0015 per month. So, LN 500 minus LN 450 will give us 0.10536051566 divided by the K, which is 0.0015. So, our time now is 70.2 months. So, anong ibig sabihin nito? That we can use our product for 70 months. So, that would be 5 years and 10 months. So, after that, we can no longer use it. So, the shelf life of the product is 70 months or 5 years and 10 months from the date of manufacture. We can also use this formula, log Ct is equivalent to negative Kt over 2.3 plus log Co. So to find K, so K is equivalent to 2.3 times the log Co minus log Ct divided by T. So let's substitute 2.3 times the log of 500, which is our initial concentration, minus log Ct, which is 491, divided by 12 months. So this one will give us the value of 0.01814357809 divided by 12. So our K now is equivalent to 0.0015 per month. So let us now try to find T if the concentration becomes 450 milligram. Using the same formula, so T will be equivalent to 2.3 times the log CO minus log Ct over K. By substitution, so 2.3 times the log 500 minus the log 450. So this is our new concentration, divided by the K of 0.0015 per month. So this portion here will give us the value of 0.10524222829 divided by 0.0015 per month. So our time now is equivalent to 70.2 months. So if you look at it, they are just the same. So kahit saan dito ang gamitin nyo na formula, you will arrive at the same answer. So again, 70 months. So 5 years and 10 months ang shelf life ng inyong gamot. Problem number 4. A product is prepared by reconstitution. The following data were obtained. So we have here the time in months and the concentration in milligram. So this is months. So 1 month, 2 months, 4, 6, 8, 10, 12, and 14 months. And these are the respective concentration. 300 milligram to 60, 200, so on. The question is, calculate half-life of the reconstituted product. Now, to compute for the half-life of first-order kinetics, we have this formula. T1 half is equivalent to 0.693 divided by K. Now, we cannot proceed in solving the T half-life or the half-life because we do not know K. So, we have to compute for the K first. Now, there are two approaches in computing for the K. So, you can use this first formula here. So, K is equivalent to negative 2.3 times the log y2 minus log y1 divided by x2 minus x1. If you recall, y represents concentration and the x represents time. So, y2 and y1. So, we can choose from here. So, we can choose our second concentration to be 260 and our first concentration to be 300. So, the time also is x2 is 2 and x1 is 1. Okay, so pwede natin gamitin itong dalawa, itong first, the 1 and 2 times. The time in the first and the second month. So, let us substitute. So, negative 2.3 times the log of y2, which is 260, minus the log of y1, which is 300, divided by x2, which is 2 months, minus 1, which is 1 month for x1. So, this one will give us the value of 0.14 per month. Another formula is this one. K is equivalent to ln C1 minus ln C2 divided by T2 minus T1. So, substituting, so ln 300 minus ln 260 divided by 2 minus 1 month. So, after solving, our K is also equivalent to 0.14 per month. So, kahit saan dito ang gamitin mo, you will arrive at the same answer. Knowing our K, we can now proceed to solving the half-life. So, T1 half is equivalent to 0.693 divided by K. So, it is equivalent to 0.693 divided by 0.14 per month. So, our half-life now is 4.95 months. Now, let us have a summary of the formula that we use for first-order kinetics. So, to solve for K, we have two formulas. So K is equivalent to ln C1 minus ln C2 divided by T2 minus T1. Or we can also use the formula K is equivalent to negative 2.3 times the log of your Y2 minus the log of Y1 divided by X2 minus X1. So the Y again represents concentration and the X represents time. So you can use either of these two formulas. Another formula that you should remember is this one. When there is an initial concentration that is given. So ln-CT is equivalent to ln-CO minus KT. From this formula, we can derive how to compute for your K and T. So K is equivalent to ln-CO minus ln-CT divided by T. And T is equivalent to ln-CO minus ln-CT divided by K. The third formula is this one. Log CT is equivalent to negative KT divided by 2.3 plus log CO. From this formula, we can also compute for K and T. So to compute for K, so K is equivalent to 2.3 times the log CO, or the initial concentration, minus the log CT divided by T. And to compute for T, so this is equivalent to 2.3 times the log CO minus the log CT divided by K. The fourth formula is computation of your half-life. So for first order kinetics, T1 half is equivalent to 0.693 divided by K. And from this formula, we can solve for K, which is equivalent to 0.693 divided by T1 half.